Well, I found an easier way to change these strips. Just take this shield off. Welcome back to the basement shop. This is part 3 of the 1950 Zenith 12-inch porthole. So let's get started. Something going on in the horizontal oscillator, looks like. Do some checking and I'll update you when I find something. All right, starting to change this 4-section cap that's up in this area right here. The one that's hard to get to. And I'm able to mount all 4 sections without putting a terminal strip. I'm just using the terminal strips that are already in the set. And I've determined that this vertical height control is bad. It's intermittent, it'll increase the height and then you turn it a little bit and the vertical collapses. So we're gonna have to figure out something for this. Getting it out was a real challenge. This is a linearity and this is a height. But they have these jump together like that with an insulator. And the only way you can get this height control out, as you can see, the tuner's in the way. The only way you can get it out is to move the linearity control out of the way and go in right here at the very bottom. So, like, even there it's tight, but there we go, see? So, I don't know about the engineering on that. Now, if the control shaft wasn't as long as this, it would make it easier. But interesting design there. No luck repairing this old one. This is a strangely made control. There's this back portion of it. And this is a resistor, or the resistive part. It sets in there. There's the 3 terminals, and they stick out back here. But anyway, this resistive network, just a piece of paper with some carbon trace on it. And it's just wore out. Luckily, I have a 7 meg. Doesn't have a shaft that sticks out, but there's a screwdriver slot. And there's 7. So it should work. See if I can get it put in there. Well, I think that's a major improvement. We had a combination of things that were bad. Of course, the height control, more caps, specifically this one right here. And on a schematic, it is this one. Goes down to a winding on the transformer, the Flyback. And this is for AFC pulse. Over here on the horizontal phase detector, 6AL5. You can see it says AFC test right there. Now, that's the phone vision jack. These are jumped. They have a plug on the top. It's plugged in. It jumps this one to this one and this one to this one. But that cap was bad. I noticed I had a lot of positive voltage here at this test point. I should have -8 volts, but I had a positive voltage, and this thing's leaky. It went right here where this new one is, and I suspect that's a paper cap in a mica housing, and you can even tell there where it's started to leak out. And another thing, quite a few resistors that had increased in value, and horizontal, vertical, both circuits. So that kind of slowed me down too, is finding all the problems and getting everything to work right. Here's all the bad parts I've changed so far. Of course, caps. There's that height control that's bad. And 1, 2, 3, 4, 5, 6 resistors. I think I changed a couple of more, and I think they ended up in the floor when I cut them out. But anyway, sound's working good. And studying up on these Zenith chassis that have the flyback issue, they tend to burn up. Luckily, this one's still okay. Could be a replacement. I don't know, but still works, so we're going to go with it. But I think the main issue that would burn the flybacks up was too much cathode current on the horizontal output tube. So I got my Syncor cathode meter out here, and according to the scale on a BG6, which is what we have, we're supposed to have between 90 and 110 milliamps of current, and hey, we've got 90. That's at the lowest end of the scale. Glad to see that. So hopefully this flyback will last a good while yet. Next, I'm going to change this picture switch, it's called. This is a switch that mounts on the front of the set. Slide the switch and it'll expand the picture from top to bottom. So this one was the one that's all busted out. Just had it jumped while I was working on the set. So I have this one. This is a new one that I have in my stash of parts, and it should work fine because the holes line up with the front panel, and just a 3-pin switch. Alright, let's see if it works. Yeah, it does expand the picture top to bottom. I want to get everything adjusted on this as well as I can with this small test CRT in before I install that 12-inch metal cone one. And just looking at the crosshatch, not too bad. Now, what else do we need to do? Well, I've checked practically all of the resistors. I think I have checked all of the resistors in this deflection circuit when I was troubleshooting. So we're good there. There are some resistors up here in the IF circuit that I definitely want to check. Here's the 3 resistors I'm talking about. They go from pin 7 to ground on the first 3 IF tubes. That one, and that one. Now this set has a 4th IF tube, and it has a 330 ohm resistor from pin 7 to ground. So we want to check that too. And indeed all 3 of the 100 ohms were bad on the first 3 IF tubes. So here they are. I wanted to show you what they check. First one, 144 ohms. Number 2, not quite as bad, 127. But number 3, 182, so almost double what it should be. So 3 new 100 ohm resistors installed. And it's 330 ohm on the 4th IF tube. It tested right on the money, so didn't change it. I noticed something on this tuner. I use channel 5 here in the basement as my RF channel, and I could get nothing when I put the channel selector on 5. I know why now. See that strip is channel 6. Okay, if we look at the dial, should have 3 on one side of it, 8 on the other side. Okay, there's 3. The next one should be 6. And it's 5. So I think what they've done, they've got 5 and 6 swapped. So yeah, I could leave it like that, but I would have to go to channel 6 on the dial to receive channel 5 on the tuner. So if we go over here to 5, it should be in between strips 4 and strip 7. There's 4. There's 7, but we have channel 6 in between. So 5 and 6 are reversed. So I'm going to swap them out, and we'll see if we can get channel 5 like we're supposed to. These strips just have a screw on each side. There's the other one. So you have to turn it down to this hole right here to have access to that back screw. Well, I found an easier way to change these strips. Just take this shield off. And there they are. I have the 5 strip put in, so now we need to put 6 back in, and it goes between 3 and 8. So there's 8. Goes right there. This adjuster right here, when you push it in to adjust each channel, it just goes into that coil right there. And I cleaned out all the dust I could. I also cleaned the contacts on these strips. I was reading about this tuner in this service manual. At the top it says a turret tuner with replaceable channel strips. In addition, provisions are made for reception under present standards of the new ultra-high frequencies, UHF, by the simple addition of an ultra-high frequency channel strips as required. So what does that mean? We look at our channel number dial. You'll notice there's a number on every slot except here. So between strip 3 and strip 13, no number. Three, 13, that was for a UHF strip. So this tuner was ready for UHF in 1950. So we'll put the cover back on, see if we have channel 5. And channel 5, yes we do. I want to try to explain this fine tuning on the tuner. Now we have a fine tuning control here. That's the one that I put the belts on, and it's working. Going all the way past and back. Now what this one is for, this is a course control, and you can adjust it for the best picture and sound.
I don't need your money, not at all.
And then you still have the front control that adjusts it, but the course one really locks it in for the best picture. Now if you turn this one to where it still works, I'll show you what happens. Go back. See, we still have a picture there, but then when we turn the one on the front, we lose it completely. So if we turn the course adjustment, you can see the picture is getting better. That's probably about the best. Now when we go to the front, we don't lose the picture. It's still there, just best right in the center. It's a well-designed tuner. I just don't know why they had to make it so big. We have a buzz control right here. This works in conjunction with that 6BN6 that Zenith's own design on that detector tube. And let me turn the volume up a little. I was on an old Western, and we went to a commercial. A lot of times on these sets, these older sets, you would get a buzz during the commercial. This one is pretty clean. So the only thing we need to do to wrap up the chassis is to change these two resistors, power resistors. I didn't have the correct values here at the shop, so I have these ordered. This is a 5 watt 400 ohm. This is a 10 watt 3400 ohm. Now what I'm going to do, I've had some 5 watt resistors ordered. I'll use, of course, a 5 watt here. I'll have to use 2 5 watts up here. I think that'll work okay. We'll find out. I had to remove the focus magnet, thinking that it would not work correctly with this little test tube. So in preparing to put the original CRT back in, had the magnet mounted, and the only difference I can see, the focus is not quite as good. It does kind of disrupt it because this is an auto focusing test tube. I'm going to leave the test tube in until I change those power resistors that I mentioned, and then we'll be ready to go back with the original CRT. All right, got rid of them old crusty corroded resistors. You'd have to put 2 together for this 10 watt, and that's the 5 watt. Before I change these, I did check the voltage drop across. The old one was 375 down to around 250, 255. And the new one, 264. This one, it was 145 on the load side of the old resistor, and practically the same. Well, it is the same. Ready for the old 12-inch CRT. Bracket that goes back under here. it's setting in there good enough. I'm not going to put that big spring on right now, but you will notice that this high voltage lead goes under that spring. You can see where it's mashed it over the years like that. So let me get my reference photos out and get this ion trap put back close to where it should be, and we'll see what happens. Well, after some adjusting on that ion trap, I had a time, even though I had a reference photo to go by. I think what had happened, the two magnets had gotten moved, rotated on the sleeve. But I think we got her. Let me show you what this picture switch does. It expands the picture top to bottom. That's normal. Now I do need to do some adjusting. We're a little too close to the bottom compared to the top. In other words, the centering's off. So I'm going to work on that. Spring's on, goes around the tube, fastens to that plastic block on each side. And there's that clip, the high voltage clip. And this rubber surround just pushes up against it. And that kind of holds it in too, even though it clips over the edge pretty well. Almost 10,000 volts. While our picture is okay, just doesn't seem to me like that there's as much gain coming out of the tuner as there should be. And if anything, if we look in the background, almost see, looks like the old days where you had a weak antenna and you see snow artifacts in the picture. I didn't want to mess with this tuner, but I'm glad I did. Pull the shield off, covers this, and in doing some checks, if we look here on the RF amp tube, pin 2 should be like 1 volt. We had about 30 volts there. So, I mean, we have an 82 ohm resistor that goes directly to ground, so how can we have 30 volts? Well, that resistor is open. Hasn't increased in value, it's completely open. And the tube's still working good enough to where the picture is not too bad, but not working the way it should. So I'm going to clip in a new resistor and show you the difference in the picture. Here we go. Look at the difference. So now that tuner is working the way it's supposed to be. So once again, another bad resistor. Of all the sets I've restored, this one has had more bad resistors than any other set. But that's okay. We found it. So I'm going to solder this in. The reason I was able to find this problem with the tuner, I hooked a Syncor VG91 up. I'm going to do some alignments on those vertical and horizontal linearity and all the controls. And could barely see the signal coming through the VG91. And I know it's a good strong signal, so that tipped me off as to some kind of problem we had. I'm glad I found it because I am satisfied with that picture. I've already made my adjustments on the vertical, horizontal. One other thing I noticed too before I changed that resistor, pins 5 and 6 on that RF tube. Pin 5 was about 140 volts. Pin 6 was about 130. So that tells me that tube was not working much. Should be 30 volts difference between pins 5 and 6. It wasn't very much at all. So glad we found that before I put all this back together. That's why I like to play a set for a day or so, just to be sure that everything is okay. Let her play a little while longer, make sure it's stable. So that wraps up part 3, 1950 Zenith 12-inch porthole. One more video where we'll be working on the cabinet, get everything reassembled, and we'll show you the finished set. Thanks for watching. We hope you've enjoyed the video. And if you did, how about giving us a like and subscribe to our channel? Thanks.